In this video, we're going to talk about proportional reasoning for scale drawings. First, let's talk about a scale factor. This is the ratio of the side length of a scale drawing to the corresponding side length of the actual object. A scale drawing is a drawing of an actual object that is either enlarged or reduced by a certain ratio or scale factor. To understand scale factors and scale drawings, we need to know what corresponding sides are. Corresponding sides are two sides that are in the same spot in two similar shapes. Let's go through finding scale factor first. On this question, it says that the following triangles are similar. What is the scale factor from the smaller triangle to the larger? We know that we're going to have an enlargement because our smaller triangle got bigger. The first step is to find your corresponding sides. One set of corresponding sides are 8 and 12. Those two sides match and are in the same spot on the similar shapes. Now that we have our corresponding parts, the next step is to put those corresponding parts in a ratio or a fraction. Now, since we're finding the ratio from the smaller to the larger, we know that we're going to have a ratio that is bigger than 1 because our triangle increased in size. So we need to put the corresponding side on the larger triangle in the numerator. That's 12. And then we're going to put the corresponding side of the smaller triangle in the denominator. That's 8. The next step is to simplify. We can divide a 4 out of both numbers. 12 divided by 4 is 3, and 8 divided by 4 is 2. 3 over 2 is an improper fraction. Let's make that a mixed number. That's 1.5. So the triangle's scale factor is 1.5. We could repeat this with two different corresponding sides, like 6 and 9. The 9 would go in the numerator and the 6 would go in the denominator. You can divide a 3 out of both 9 and 6, getting you 3 over 2. Notice that that matched? It would work the same with 10 and 15. Let's look at another example. This says that the following rectangles are similar. What is the scale factor from the larger rectangle to the smaller rectangle? So on this one, we're actually going to go opposite. Our rectangle is getting smaller. The first step is to find your corresponding sides. 45 corresponds with 9. Now, since we're finding the ratio from the larger rectangle to the smaller rectangle, we know that we're going to have a ratio that is less than 1 because our rectangle decreased in size. So on this one, we need to put the smaller rectangle side in the numerator. That'd be the 9. And then we need to put the 45 in the denominator. What can you divide out of 9 and 45? You can divide out a 9. That gets you 1 over 5. So in this case, our scale factor was 1/5. If you had chosen 20 and 4 as the corresponding sides, we would get the same ratio. 4 over 20 simplifies to 1/5. Now let's go through an example with a scale drawing. This one says that Sam has a toy race car that's a replica of his favorite sports car. The toy car is 3 centimeters wide. Use the scale factor to find the actual width. We know the scale is going to be 2 centimeters equals 6 feet. When you solve questions like this, the first step is to make the scale a ratio. So we have 2 centimeters over 6 feet. Now we're going to set up a proportion by matching up corresponding parts. Since we have centimeters in the numerator for our scale, we need to have centimeters in the numerator on the other side of our proportion. And we have feet in the denominator, so we need to have feet in the denominator on the other side as well. Now we can plug in what we know. We know that we have 3 centimeters, so that's going to go in the numerator. We're looking for the actual length, which will be in feet. The next step is to cross multiply. We know we have 6 times 3, and that's going to equal 2 times x. 6 times 3 is 18, and then we can divide by 2 to get x by itself. The actual width is 9 feet.